Alright, how do we solve systems of linear equations using substitution? Well, let's remember what a system looks like. If we have a graph and we have these two lines, these are ugly lines, the solution to this system is the point where they intersect, right? So right there, they have the same x and y. And because they have the same x and y, you can substitute the variables in for each other in the equations. Alright, so let's take a look at an example. Here we have a system of two equations, y plus 4x equals 8 and y minus x equals negative 7. Step 1 is going to be to solve one equation for a variable. Now this doesn't matter which variable in either equation it is. We just solve for whichever one seems easy to solve for. So like I'll just take this y plus 4x equals 8. Y is pretty easy to solve for. I just have to subtract 4x from each side. So y equals negative 4x plus 8. So now it's important to remember that at some point these y's are going to be exactly the same, and so are these x's. So because these y's are the same thing, we can substitute the expression from the equation 1 for the variable in equation 2. So I'm going to take this negative 4x plus 8 and substitute it in for this y in the other equation to get negative 4x plus 8 minus x equals negative 7. So what was the benefit of that? Now I have an equation with just one variable that I can solve for. So my next step is just to solve this for x. I'm going to solve this equation. So I combine like terms. I have negative 5x plus 8 equals negative 7. Subtract 8 from each side. Negative 5x equals negative 15. Divide by negative 5. And get x equals positive 3. And that takes us to our last step. Now that we know what x equals, I can plug it into either equation that we started with to solve for y. Now what I suggest doing is plug it back into the equation that you already solved for y. And I'll show you why you would want to do that. So we're going to take this x equals 3 and we're going to sub this back in for this x. So now I get y equals negative 4 times 3 plus 8. And you see the reason why I'm doing this is because it's already set up for y equals. So whenever I solve this, negative 12 plus 8, I get y equals negative 4. There was not a lot of moving around of equations that I had to do. So now I've got my x and my y. So these two lines would intersect at the point 3, negative 4. And that's the solution to this system of equations. Okay, so let's try that one more time together. Here I want to solve for whichever variable seems easiest. Here I have 3x minus 2y equals 11, x plus 2y equals 9. The easiest variable to solve for is this x right here, and that's because it's just a single x hanging out. So I can say, okay, x equals negative 2y plus 9. Now that I know what x equals, I can replace the x in the other equation with this. So I can say 3. Now I'm replacing the x with negative 2y plus 9 minus 2y equals 11. Distribute the 3 and then combine like terms. So negative 6y plus 27 minus 2y equals 11. I'm going to combine my like terms. Negative 8y plus 27 equals 11. Subtract 27 from each side. and we get negative 8y is equal to negative 16. Dividing by negative 8 gives me y is equal to positive 2. Then I'm just going to plug this right back into the equation that I saw for earlier. So x is equal to negative 2. Now I'm going to replace the y with what y equals. Y equals 2 plus 9. So x equals negative 4 plus 9. X equals 5. So the solution to this system is 5, 2. And don't forget that if you ever want to check your solution, this 0.52 should satisfy each of our original equations. So just to show you right over here, 3 times 5 is 15 minus 2 times 2, so 15 minus 4 is 11. And on the right, replace the x with 5 plus 2 times 2 is 4. 5 plus 4 is 9. So you can always check your solution. Alright, here's one for you to try. And as you can see, this first equation is already solved for y. So you can use what this y equals and substitute it into this equation. Alright, go ahead and pause the video, and we'll come back together in a moment. Alright, so hopefully you plug this 3x plus 8 in for this y. And once you distribute the negative and combine like terms, you're at x minus 8 equals negative 12. Adding 8 to both sides gives us x equals negative 4. Plug that right back into this x. 3 times negative 4 is negative 12. Negative 12 plus 8 is negative 4. So we have an x and y, both are negative 4. The point where these two lines intersect is negative 4, negative 4. Okay, just like with any equation, sometimes we have some special cases. So let's look at a couple. Here we have 5x plus 2y equals 6 and y equals negative 5 over 2x plus 1. So the second equation is already solved for y, so I'm just going to replace the y in this equation with what y equals. So 5x plus 2, and then replace this y with negative 5 over 2x plus 1 equals 6. Whenever we distribute the 2 here, we'd have 5x. These 2's, whenever you multiply, will just cancel, so you have minus 5x plus 2 equals 6. Well, hopefully you notice that 5x and minus 5x, these cancel, and I'm left with 2 equals 6, which is never true, right? So if you end up in a point like this, these have no solution. And if you end up in a no solution, we have to think back to, okay, what's actually happening with these lines? With systems of equations, when do you get no solution? Oh, these must be parallel lines. Alright, here we have one more special case. Our first equation is already solved for y, so I'm going to replace the y in the other equation. 4x plus 6 times negative 2/3 x plus 1 equals 6. Distribute the 6 here. 4x, 6 times negative 2 is negative 12 divided by 3. It's negative 4x plus 6 equals 6. The 4x minus 4x cancels, and I have 6 equals 6, which is always true. So in this case, the solution, there's nothing even to plug in back over here. Everything, the x's will always cancel out. Our solution here is all real numbers. Or just this symbol right here. And with systems of equations, all real numbers just means these are the same line. And that's how we solve systems by substitution.